virtual live, at least in the webinar. So I'm the head of the Earth System Modeling section at ECMWF. And today we're going to talk about a perspective from industry. And we have basically 3 companies invited who will give a presentation and one talk each. And then afterwards, we will have a couple of more general questions, and then we will start the more general question and answer session, where we will pick up the questions that you will post on the chat. And for this, please feel free to kind of shoot along whenever you have a question. You can already put it there, and you can either address specific speakers, will basically then be part of the panel later on, or you can also have more general questions to everyone. That's really up to you. And we will try to kind of pick up as many questions as possible, given the time constraints. Okay, tomorrow there's going to be another webinar where we're going to focus more on the SMEs, so the small and medium-priced enterprises. But today we have kind of more of the larger companies invited in the room. And also the specific webinar has also heavily been influenced by IFAB, who is kind of organizing the MOOC together with ECMWF. From ESAB, I would like to invite Laura to kind of give a very quick presentation and introduction to this webinar as well. Laura, the floor is yours.
Thanks, Peter, and welcome to this webinar, an industry perspective on machine learning in air system science. My name is Laura Mortini. I'm the head of communication and marketing of IFAB, the International Foundation on Big Data and Artificial Intelligence for Human Development. Today, 3 IFAB members, BIP, Leithà Unipol Group, and CRIF, are going to show how to apply machine learning in weather and climate in solving real problems, for example, by developing sustainable application. So before starting the discussion, I would like to wish all the best to the participants, and also would like to thank ECMWF, all the speakers for their contribution, and everyone who made this webinar possible. So enjoy it.
Thank you very much. I don't think we should add anything else at this stage. We should just dive into the talk straight away. So we're going to start with a talk by Alessandro about the BIP. Alessandro, please go ahead.
Thank you. Thank you very much. Can I have the rights for sharing the presentation, please? So I can. Thank you very much. Okay. Here it is. Can you see the presentation? Yeah.
Yes, we can.
Great. So thank you, Peter. Hello, everyone. It's so nice to be here and having the chance to share our experience with you. I see there are really a lot of people from all over the world. So welcome to you all. I'm Alessandro VOLPE. I'm the Data Science Competence Manager for BIP, which is a leading global managerial consulting firm. In BIP, I supervise the Italian data science team, and I coordinate research and development activities, projects, and other competence development programs within BIP in the data science space. As the title says, today, to contribute to this MOOC, I will discuss how weather data have been used in some of our machine learning projects, which we developed over the years, to empower the decision-making processes based on machine learning. Okay, so before digging into the contents, I'd like to speak a couple of words on the unit I work for in BIP. The unit's name is xTech, which stands for Exponential Technologies. We are a global team counting more or less 600 people with different skill sets. In its entirety, xTech offers what we call the smart integration services. So we design the adoption strategy for companies. We conceive and implement data-driven solutions for them, and we integrate our data products in our clients' environment and automate operational workflows. Our data science practice counts a little over 70 people, and it's actually the largest professional one in Italy, according actually to LinkedIn. Okay, enough with the presentation. Let's talk about machine learning. So that's actually what we're here for. As mentioned today, I'll share some of our experience with you. I'll describe how weather data was used in 3 different machine learning projects in industries, in oil and gas for demand forecasting, in telecommunications to empower operation and maintenance processes, and in consumer retail to optimize the scheduling of customer appointments in store. Let's start from the first one, from energy demand forecasting. We have been working on this project for some years now. Our client is an Italian transmission system operator whose business consists in dispatching liquefied natural gas received from producers and shipped to distribution companies or directly to industrial plants. Some years ago, the Italian government instituted big subsidies, economic subsidies, to favor the competition on the energy free market. And so from that point on, the need for our client was to provide Italian authority each day with a correct estimation of the volume of natural gas delivered across Italy through their network for the following day. If the presentation error is less than 5%, the company receives economic subsidies. Otherwise, they shall pay a fine, and both the subsidies and the fine are proportional to the error committed in the forecast. So the better the prediction, the better it is, economically speaking, for the company. We worked on several models versions over the years to improve what was being done before 2017, when they used typically classical time series forecasting models, which accounted only for a limited number of variables. Our last deployment was some years ago, and it consisted in a dynamic ensemble of 6 neural networks, each of which was specialized on a different market segment and a different season of the year. A set of neural networks are active during the whole year, and another set alternates to provide better forecasts specializing on winter data versus summer data, since typically the trend of gas demand in Italy is very different, of course, in the two periods of the year. So we employed several data sources for the training of the models, electricity generation, because as you may know, natural gas is also used in power plants to generate electricity, the inlet and outlet measurements of gas flowing in the company's network, other company official data, such as the balance sheet, the level of gas storage in the storage plants, etc. And among external data, calendar data and holiday variables, which impacted the forecast, and of course, weather data. We included two types of weather data, actuals and forecast daily measurements of the temperature, humidity, rain and snow. As you can see from the chart on the right of the slide, weather data is highly correlated to gas consumption. In fact, specifically with the residential component, which is the largest one of the three that we considered. This is quite natural, actually. In fact, it can be easily interpreted since people generally turn on their heating at home when the temperature falls, and therefore, of course, gas demand increases for the country. February 2021 is a clear example of this, and you can see it in the little circle on the bottom of the slide. In fact, in that period, Italy experienced a particularly cold winter, and this significantly increased the gas demand for residential heating in that month. Our forecasting system was developed in incremental iterations and was deployed in several stages with a new improvement every more or less 3 to 6 months from 2017 onwards. The improvements were made in particular to the feature engineering stage and to the model architecture of the neural network ensemble. And all these improvement and tweaks to the models allowed to progressively reduce both the forecasting error variance and the mean value or mean absolute percentage error by several percentage points. And this allowed our clients to capitalize on the government economic subsidies, achieving a cumulative economic upside of about 10 million euros in 2022 alone, and over 30 million since the first model deployment, which in our opinion is quite a remarkable result. The second example I would like to present to you is instead in the telco industry, where we implemented a predictive maintenance system to prevent air conditioning faults on the network radio sites. You can see a sketch of the radio sites, a little one on the left of this slide. The outside structure of the radio site is exposed to the open air, while the internal structure, you can imagine it as a large room full of servers and other economic equipment, which are cooled down and kept to operating temperature by a powerful air conditioning system. You can imagine it as a residential one, just more powerful. All the components in the internal structure are core for the functioning of the network site. So if they fail, if they break down, they compromise the whole site. The internal site, the internal structure is sheltered from the outside, but the isolation isn't perfect. So actually, weather conditions partially affect the internal environment. Okay. The system that we were asked to implement by the client had the objective of anticipating air conditioning faults by more or less 7 days to allow a better planning on the maintenance activities to save both on the corrective maintenance, so when it breaks, and on the scheduled intervention, so intervention that are already scheduled for the year. Okay. The machine learning system that we implemented as an anomaly detection algorithm at its core, it is a 12-level autoencoder, 6 levels for encoding and 6 levels for decoding. And each layer is a bidirectional long shortened memory neural network. The reconstruction error of the autoencoder is used to define which time series in input has the highest relevance, and the time series with the highest reconstruction error is typically linked to the higher probability of failure of a component. Besides the asset inventory and asset characteristics, the time series data sources that we use for the model training consist of sensors data and other sensors generated alarms, work orders of past maintenance interventions, and guess what, also weather data. In particular, data related to temperatures, humidity, rain and snow. Data in the process is pre-processed, aggregated and refined to feed the model. And then an explainability module is also implemented to allow interpretability over the faults predicted by the model and allowing the correct team, the correct squad to intervene on the site based on the type of fault which is detected by the model and the explainable AI module. The output of the model is stored in the company's operational systems and is presented on a business intelligence dashboard, which is monitored by the operative team, allowing the planning and maintenance interventions upon the need. So when the model actually indicates that a component is about to fail. Here you can see an anonymized version of the operational dashboard where relevant KPIs such as the fault probability and the risk factor associated to each air conditioning asset are monitored for letting a maintenance squad intervene in case of need, so in case there's a high risk of breaking. From the feature importance plot that you can see on the left of the dashboard, you can see that temperature data is affecting quite significantly the model risk evaluations. And this is naturally expected since the hotter the environment, of course, or the higher the temperature on the outside, and the more stressed the air cooling system will be to keep the equipment at the correct operating temperature. The overall results that we achieved were quite satisfactory. We allowed the company to save more or less 100 corrective visits and 600 more or less preventive ones each year with respect to the baseline classifier. And this allowed the company to save more or less 200,000 euros each year for the operation and maintenance. Okay, for the last one, I'd like to share a less peculiar example of usage of weather data in industry. It was a project that we delivered for a national retailer, again in Italy, who owns and manages more or less 600 physical shops on the territory. The request that the client had was to develop a system to optimize the appointment diaries between the agents in the shops and the customers in order to minimize the probability of customers not showing up to booked appointments. Weather, in this case, actually played a role over the possibility of people not showing up to appointments. Let's see how. Okay. We observed that both the temperature and the rain impacted significantly the no-show rate, as one can in fact expect. When it rains, typically I don't have that much will to go out of my home. In the chart on the right, you can see percentages. These are referred to the probability of customers not showing up to appointments, and we derived these ones from some exploratory analysis. Sorry. The temperature drops reduce the show rate of customers, both young and old ones, of about 5 percentage points, while the rain instead has a more evident effect. Okay, in fact, both young and old customers have a higher chance of not showing up to appointments when it rains, with old customers impacting more than younger ones, but the younger ones more sensitive to small temperature variations. We decided to use weather forecasts to better optimize the appointment scheduling. And besides weather, we actually use, of course, other information related to customers, to shops, to personnel. Mainly all this information collected at the time that the customer does the registration for the appointment in the store. The model that we implemented consists in an operation research problem, more specifically a custom allocation optimization model with the objective function that accounts for the economic value entailed by each appointment. And it weights both the costs of operation of the appointments and the revenue associated to the conversion probability, so the probability that the customer actually buys something in the store. The constraints of the model represent the availability of the shop, so when it's open and when it's closed, the availability of the personnel, so the shifts of the people that works in the shops, and the correct allocation of customers to the correct time slots that they prefer. In the chart of the right, you can see the results of a simulation that we conducted to tune the internal parameters of the model. We simulated the impact of proposing different slots to potential customers, different time slots to potential customers, considering all internal and external factors, so considering also the weather forecasts. And in this process, we let the customers choose the favorite time slot for them. In the chart, you see many lines. Each line represents the expected economic impact of uniformly moving the appointments to the respective top to worst preferred time slot for each customer. If the appointment is scheduled on the customer's best slot, you have the highest curve. That's because the chance of not showing up to appointments drops because it's the favorite time slot for the customer. And so the economics of the business case are higher. What was proved by us is that letting the customer choose their favorite slot entails an increase of 13% of revenue in the worst case scenario, up to 22% increase in the best one. So we help the retailer to optimize the appointment booking process by suggesting 4 optimal slots. The tool suggests this once, considering also weather forecasts, and the customer picks the favorite slot among these 4. At worst, the retailer knows that the upside with respect to the former booking procedure is at least a 13% increase in revenue, which is, again, quite remarkable in our opinion. Okay, that's it for me. I hope the sharing of our experience was interesting for many of you. Of course, I'm available for any question that might pop up in the following question and answering session. Again, thank you for your attention, and the word back to you, Peter.
Thank you very much, Alessandro, for the very fascinating presentation. We have already more than 350 participants, so it's great that so many of you are here, and also it's great to see that the spread over the entire globe where the people are coming from is really quite remarkable here. We had questions about whether the slides are going to be available. The answer is we don't know. In a sense, we will need to kind of come back to the speakers to ask for IP issues and stuff like this, but we will try to make them available later on the user forum. Without further ado, we will go to the second presentation by now. So we now have a presentation by Leithà, and Frederica is going to give the presentation together with Filippo. Frederica, the floor is yours.
Thank you, Peter. So now I share the presentation. Perfect. So I'm Federica Dominoni, and here with us there is also Filippo della Casa, that is the head of data science in Leithà. I'm innovation manager of UnipolGroup, and we would like to present you some real use cases that we done in Leithà in terms of weather climate for the loss prediction and the loss prevention. So just to give you some quick words that maybe you know UnipolGroup, that one of the most large insurance company of the Italian market, but Leithà is a sort of niche of UnipolGroup because it's an insurtech company that develops the data-intensive solution application or components of application with an agile environment. The main focus of the Leithà is to have a clear mandate to gain competitive advantage to enrich the data assets of the UnipolGroup. In the other end, we would like to differentiate our perspective and expertise, for example, to develop internally new technologies and expertise to UnipolGroup. How is composed Leithà? Leithà is composed by 17 employees specialized in the data mining, big data analytics, and artificial intelligence and machine learning skills, and is an excellent center in the data science and computer science of UnipolGroup, providing new solution and innovative solutions in 2016. We would like also have to share with you that we have a specific group of expertise with core software engineer components, and moreover, Leithà has a specialized team involved in the exploitation in the weather and the climate data for insurance sector. These capabilities and skill are good know that Leithà delivers project in different business of the insurance tech sector in terms of algorithm, natural catastrophe modeling for insurance and reinsurance, with the support of machine learning and artificial intelligence for information extraction from the weather and the climate data. While for the motor sector, instead, Leithà is specialized to develop architecture able to analyze telematics claims and trip reconstruction. And we also are able to define claims management instrument and fraud analysis for the entire business of the UnipolGroup. Going in deeper on machine learning and weather climate use cases in insurance sector, I would like to present you the use cases that Leithà has developed end-to-end. So in terms of application and in terms of analytics. The first case is related to the part of the loss prevention, and the second one is the prediction side. So with the project Zeus now, the main focus is to provide a short-term prediction of severe climate events observation from meteorological radar every 10 minutes in 1 kilometer pulse resolution. We use last 40 minutes of observation data to predict the 3 hours as a proxy for precipitation. So we develop generative adversarial neural network technology, and this is the same technology exploited for the deepfake generation. This is the example that show you what happened, for example, in September of the last year in the Marche region. There was a flood which particularly involved the areas of Ancona and Pesaro Urbino that unfortunately caused 12 victims. On the left part of the side, you are able to see what the prediction of the event, while in the right side you can see what really happened. So the graph on the right part show so this is an example of what in terms of prediction and real prediction we have analyzed. And this is a part that show the comparison of the predicted model, while because in the blue line, as you can see, there are the predicted data, and in the red line, there are the observed data of the radar reflectivity for a particular event in Austria that is counting near Ancona. And as you can see, the two events are more or less overlapping and provide a similar results. So thanks to this model that we call Zeus now, we are able to send alerts to our customer up to 2 or 3 hours in advance, and consequently, our customers are able to protect their asset, such as, for example, a car. And in conclusion, this case is an example of win-win strategies. Why? Because customers are able to protect their assets and in advance, and also, of course, from the UnipolGroup perspective, so in terms of insurance sector, we are able to reduce our claims and our cost. And I would like to present also another example for the loss prediction. So the loss prediction for us is particularly important because we are able to focus to readily predict aggregate number of cost and claim as a consequences of severe climate events. We use, for example, the weather radar observation for physical description of weather events, and UnipolGroup customer exposure as a town aggregation level in the Italian country. So Leithà implemented a real use cases of machine learning regression algorithms, and to derive, for example, an estimate of claims frequency and costs. In conclusion, with the Metropolis project, we are able to estimate near real-time effort needed for the entire claim settlement process following an event both for property and claim and motor sector. So this is an example that the total cost amount related to an event is useful also for the reservation cost that we have in the insurance sector, and of course in the reinsurance proposed. So I would like to present you use cases that there was an event registered in October 2021 in Sicily, and the event was classified as a tropical cyclone called, here in the news you can see the name Medican, that is a union of words that means Mediterranean and hurricane, and the cyclone arose the area between the dry masses of the North Africa and the most air masses from the Atlantic. So the cyclone hits the part of the southernest of the Sicily, around the area of Catania. And here, the cyclone caused a lot of gusts of winds, for example, heavy precipitation and sea storms along the coast of the Sicily region. The graph here shows the results of the actual number of claims with the green bar, as you can see, and the predicted metropolis value, the blue bar. So as you can see, the error of the model are underestimated the value by 5%. While the bottom graph show you the result, for example, of the purple bar that is the actual comparison between of the cost of loss, while the pink bar represents the total cost of loss predicted. And here the result, the model overestimated the model because the cost was by 10% more. So as you can see here, there are just an overview of the good result that the model present to us. In the scatter plot graph, you provide the performance of the model in terms here of the cost and here in terms of loss. So as you can see, both of results are good. We think that they are pretty good because for a limited range of event, you are able to see the frequencies and the loss that perform very well. But probably these events that are a particular outlier are so rare, and the model maybe are not able to describe the training data set. So this is an example that Leithà provide in terms of algorithm and machine learning in terms of claim management and weather events. If you have some question, maybe we can discuss in the Q&A section. And this is for us. We have finished.
Thank you very much, Federica. Very interesting. Let's just jump straight away into the third talk from PAOLO, talking about the duet CRIF. I'm sure the slides will come up in a second.
Yep.
Perfect.
Okay, thank you, Peter. Hello, everybody. I'm Paolo Gambetti, data science leader from CRIF. I'm very excited to be here because today I will have the occasion to present you the first development that I made when joining CRIF. So it's really a great occasion for me to be here. So thank you. So let's start into the presentation. First of all, I would like to share with you our experience, starting from a question: who developed these weather-related risk scores for the insurance market that I will present? Well, this is a development that is a result of a partnership between CRIF and Red Risk. CRIF is a global company specialized in business information, credit solutions, outsourcing and processing services, and in advanced analytic solutions for different industries, banking, utilities, and also insurance companies, as the case study we will see today. And Red Risk is a highly specialized firm in the consulting sector related to natural catastrophe and man-made disasters, and as CRIF is active in many industries, banking, insurance, and also Red is providing consulting for very important public institutions such as government and the World Bank. So I know there are colleagues from Red among the participants. So thank you a lot for your contributions in this project. Let's go on with a bit of motivation. So today there is widespread scientific evidence regarding the increase in the frequency and severity of weather-related events. This is especially true for meteorological events that can be thought as whatever can be ascribed as a storm, so windstorm, snowstorm, rainstorms, and hailstorms. Of course, this increase in economic losses due to meteorological events is due to a larger number of exposures that has been observed and created in years, but it is also the result of climate change, which is indeed influencing the frequency and severity of weather-related events. This is something that we know, and as private citizens and companies, we should ensure. But unfortunately, among Europe, there is a very different culture with respect to insurance against weather-related events. For example, here in the slide, we see two cases, very virtuous example of Netherlands, where losses amount to 9,000 million euros, which is almost 1/10 of the losses we experience in Italy due to weather and climate events, but unfortunately the amount of insured losses is the same for the two countries. So there are reasons why European countries largely differ in terms of percentage of insured losses for weather-related events, and these slides actually would like to communicate that in Italy, for example, there is really a large profit pool that can be exploited in terms of providing insurance companies with solutions for creating products for mapping weather-related risks on the territory. Actually, this is also important because natural events actually represent the main driver of economic losses for insurance companies. So you should know that on top of the classic insurance policy of third-party liability that we need to have for driving, we can buy ancillary guarantees. Among ancillary guarantees, there is a possibility to buy coverage for damages due to natural events, weather-related risks. And we see here that although the amount of contracts for natural events is way lower than contracts for ancillary guarantees for windshield insurance or theft insurance, the amount of damage is really, really huge. So it is very important for insurance coverage to get access to advanced analytic solutions and scores that can help us to identify the areas and the customers that are more exposed to weather and catastrophe risk. So what we did together with Red Risk is to use machine learning models to provide insurance companies with weather-related risk scores. So what are the determinants of weather-related risks for the motor vehicle insurance? There are three determinants. Clearly, there is the meteorological dimension, so the probability that an area will be hit by a certain natural event with a given severity. This is clearly the main driver of weather-related risk, but there are other two important dimensions that our model will try to capture. The first is client risk, so the behavior of the client of the insurance company. So the possibility that even having an access to covered parking space, he or she will park the vehicle outside. So client risk amounts to approximating the level of care and attention of client's assets through socio-demographic variables. And the last dimension is vehicle protection. So the possibility that in that area there will be essentially covered parking spaces in the case weather-related event will occur. So which kind of data we used for capturing these dimensions? Clearly the main component is meteorological risk. So we involved a very long time series of weather data from the ERA 5 land project. Actually, we used very long time series up to 30 years of hourly data in order to be able to estimate quite precisely the probability of severe and rare events. These are spatial databases that are evenly distributed in space. They are available at a spatial resolution of 9 kilometers, and we apply downscaling to bring the meteorological information up to 1 kilometer, so to be able to capture the very local nature of some of these phenomena. Think about rainstorms or the determinants of hailstorms. On top of this, we consider basic indicators, so data on precipitation, on wind speed, changing temperature, and so on. And then from raw data, we also derived additional indicators, such as the probability, for example, that the precipitation will reach a certain threshold that will in turn determine damage on vehicles parked on a specific space. And together with RED, we spent really a lot of effort in order to identify the most precise threshold for determining damages due to different natural events on vehicles. And eventually, we also derived what we call advanced indicators, such as a hail probability index, which is not available publicly at a very granular spatial resolution. How we derived this indicator? We essentially computed the probability that a specific territory will be associated with the conditions for hail verification, such as particular combinations of the convective available potential energy, freezing level, and wind shear. On top of meteorological variables, which are clearly the most important data, our machine learning algorithm also make use of news-based indicators. So indicators that are derived thanks to the use of text analysis techniques on news that we collect from newspapers in Italy, referring to particular natural events. Why we use news-based indicators on top of meteorological data? Because the meteorological data alone is not enough to capture the local vulnerability of an area to meteorological related damages. The reason is very simple. If you get articles from newspaper speaking about natural events, well, if there was a natural event without damages, probably there was not even the occasion to write an article about it. So news-based indicators are really, really important to capture the vulnerability dimension of a territory, on top of course, also morphology data. Last but not least, we also try to feed our algorithms with data that capture the dimension of vehicle protection and client risk. These are socio-demographic data that are measured at the level of the census cell, so really granular spatial data, and refer to variables such as population density, population wealth, the type of buildings, and all those variables that can give us an idea of the morphological profile of the city, so as to approximate the probability that in a specific area there will be available covered parking slots, and that the behavior of clients living in that area is coherent with a, let's say, a strategy for covering the vehicle in a parking slot in the case a particular weather event will realize. What is the result of these algorithms that consist in boosting algorithm, in gradient boosting algorithms? These algorithms, they essentially predict the frequency of claims and the loss ratio, so a proxy of the damage due to weather-related events. Those dependent variables are then discretized in a score from 1 to 6, where 6 represent the highest degree of risk, which is then plotted on a map. So it's a score which is normally provided at the level of individual census cell to insurance companies for all the Italian territory. In this case, we are extending the solution also abroad. The result of this score is actually highlighting notorious areas at high risk, at least for Italy, such as the Po Valley, the Abruzzo region, which has been hit historically by very severe hail event, which is the most important determinant of weather-related risk for vehicles, and the northern regions. So at the macro level, we verified indeed that this score is coherent with historical evidence regarding weather-related risks and past claims for essentially the catastrophe-related insurance policy. But what is very interesting is that thanks to the use of variables spanning information on clients' behavior and the degree of vehicle protection, we were also able to capture the local nature of weather-related risks. So we isolated some very small towns, such as this one on the Adriatic Sea coast, which is associated on average with a very significant, level of weather-related risk. And we verified that in the same city, the weather-related risk score was different on different places. We see here a place, a census cell, where the score was 4 on 6. So quite significant level of risk. And this was a census cell characterized by 3-lined avenue. And there was no way in this census cell that insurance clients were able to park their vehicle in a covered parking slot, because there are no covered parking slots in these in the buildings located in this area. While within the same city, there was another census cell characterized by a score of 2/6. This was a newly built area of the city characterized by quite large villas with covered parking spaces. So we backtested the weather-related risk score on 2 dimensions, the macro level dimension. So we backtested the fact that the score on the overall territory of Italy was able to capture the regions and the areas most exposed to weather-related risk, but also at the level of cities themselves. In terms of results for insurance companies, we verified the frequency and the average loss ratio that was communicated by the score on each of the classes. What we found is that this weather-related risk score has really a high discriminating power on both dimensions, on both the dimension of frequency and on the dimension of the loss ratio. For example, here we see that as for the frequency, which is the blue line, census cells associated with a risk score of 6 were associated with frequency of weather-related claims that were 4 times the average frequency of the portfolio, while in terms of loss ratio, they were associated with loss ratios that were up to 6 times the average loss ratio of the portfolio. So a really powerful instrument that is able to identify non-residual risk clusters due to weather-related events. So I don't think I have a slide to thank you, but I thank you very much for your attention, and we see during the Q&A session for your question. So thank you very much.
Thank you very much, Paolo. Very interesting talk. In particular, this last figure here is kind of quite impressive. It shows that that it makes sense to kind of look into these kind of things, really. Let's start now with the question and answers. So I'll start and kick off the discussions with a couple of pre-prepared questions, but then at some point we'll take also over the questions that are posted here, and please continue posting them. Please be specific in a sense, like if you refer to a specific part of the discussions, please make sure that you also state where it's about, because otherwise the question may get lost. Let's start with the first talk with Pip and Alessandro. What are the challenges that you as a company are facing if you develop machine learning tools at the moment, and kind of in particular if you apply machine learning to real world problems? Often the problem is the data, and what are the problems when dealing with weather data, for example?
Mm-hmm. Okay, thank you. Thank you for your question. So, well, besides the technical issues of developing machine learning workflows, such as dealing with data quality, model generalization issues, or handling model bias, our experience today shows that companies, at least in Italy, okay, where we are mostly focused, are struggling building confidence and trust in AI in decision-making processes in industries. This can be explained by the fact that there's still an important cultural transition going on, but there's also an evident struggle for many IT departments in managing the complexity of a machine learning software in production and all the serving environment. Weather data have proven to be a valuable asset to inform decision-making in machine learning-based systems, but it's, however, important in our opinion to understand how to select the correct information and how to process it to keep the proper dimensionality under control, and to ensure that the model interpretability and actionability for the final users who will use the outputs of the models. One relevant attention point, in our opinion, is also the use of weather data. In the use of weather data is the uncertainty that is linked to the forecasts. So we know that the forecasts are more reliable over a short time frame with respect to a longer one. So, for example, in the last example that I shared for the national retailer, weather is accounted in the model only for the optimization of the appointment scheduling in the following week with respect to the moment of the optimization. Otherwise, is not considered by the optimizer. So this is my opinion with respect to the question.
Thank you very much. Let's go to the second speaker, Federica, also Filippo, who's also in the call, also from Leithà. In the future prospects, basically, what role do companies like yours basically are playing in the context of climate change, in particular in the case of insurance? And I think there was also a question in the Q&A actually that was asking what the insurance how climate change will impact insurance cases, and also how you calculate those insurance risks basically.
Yeah, thank you, Peter. Very shortly, and it's actually a very good link with Paolo's presentation, because he already has shown some figures on, how much the book of insurance companies is already exposed to climate risks. It's just because of the mandate of the insurance sector in its entirety, which is in the end, protect people from risks and undertake that kind of risks. So the very same role that is already played by the insurance companies in climate risk, I would say, is for sure affected by climate change. And this means that we just need, even more expertise in terms of being able to manage this kind of data to properly price the risks. Paolo already, shown some figures on how climate risk affects car insurance. You can imagine what happens when you insure property. You can imagine what happens when you insure kind of, temporary unavailability of services for enterprises, small, medium enterprises, or large corporates. So climate change just is an additional element for keeping up to speed with the skills and techniques and technologies that are needed to handle properly climate change climate variables, especially when it's about prices, because one of the specificities of doing data science within an insurance company is that data goes directly into the price of the product itself. I mean, pricing an insurance contract is predictive modeling ante litteram in a way. The very first thing that you must be able to do when someone shows up at your insurance agency is predict the frequency and severity of the risk that you are underwriting.
Yeah. Isn't there also like a more fundamental problem here in a sense, like you will never have the right data? I mean, if you train from nowadays climate and you run into climate change, so isn't there kind of an implicit risk that you will never have the right assumptions for your machine learned models?
For sure. It's an implicit risk, and for sure we will never have the proper data. And the only thing that we can do is kind of adjust a proper pricing based on trends, and adjust what is called the kind of the need for premium to cover for the trends in terms both of frequency and severity of these kind of events due to climate change. But yes, there's an issue about availability of data and reliability of estimating trends.
Yeah, I know that there was also spawned a discussion on the user forum outside of this webinar, basically, on how climate change will impact on training data, basically. For the last talk, for PAOLO and CRIF, I mean, basically, what are the main factors that must be present in a company to be able to work with weather and climate data and these kind of problems in principle?
Okay, so well, I would say that the first slides of my colleagues from Leithà and BIP help to answer this question. I think that the main ingredient for working on these domains is the possibility to create an interdisciplinary team. This was clear from the first moment we tried to approach the development of these solutions for insurance, but what we did also when we developed physical risk scores for companies or properties, as Filippo mentioned, it was clear from moment one that it's not a challenge that you can do alone based on your business-specific knowledge. So you need to create an interdisciplinary team, being sure that you have access to the gold standard of data and methodologies. And in this case, we created the team with Red for this reason. You need to be able to investigate what are the synergies within your team. So after the creation, to which industry you can support, and most importantly, you really need to learn from the technical part of the team how to simplify very important concept that you need to explain to the final clients. And especially when we deal with these very, very particular topics, such as weather-related modeling, you need to learn how to transfer this concept to clients that are not used to work with these instruments, such as banks, for example. We recently observed regulatory wave in the financial world where banks need to provide disclosures on physical risk exposure. So they have to get acquainted with completely new terminologies that are outside their business, new data, new methodology, and understand how integrating meteorological modeling within the credit risk model. So the key aspect for us is the ability to create an interdisciplinary team.
This fits very well to a question that I just see here in the chat, which I'm going to publish now. So how can professionals from meteorological or remote sensing domains get into industries like these, especially considering most of their work would have been in a non-business oriented environment? So I think I will add to this question to some extent, like, would you hire, for example, meteorologists for being meteorologists, or would you also hire them for being smart people who have some sort of background in statistics, mathematics, physics, and so on and so forth? Who wants to take that question?
I can take the question if you wish.
Yeah.
Yeah, I mean, for sure, this is a kind of background that we are in a way. I'm speaking for being a tech company within an insurance incumbent. We are in a way at the intersection between techniques, technologies, weather, and insurance. This very tiny intersection is getting larger and larger, fortunately enough. But the business the domain expertise in terms of the data, in terms of the methodologies, the data is detected, collected. So again, here you mention the question mentions remote sensing. We have hired in the past experts in the remote sensing domain, and then willing to be a bit more advanced in terms of software engineering. But yes, we do need absolutely this kind of expertise, and then build what is needed to deploy solutions into the productive environments of the company. But for sure, this is a domain where a deep expertise in that domain, in terms of gathering the proper variables and attaching the proper meaning to a proper whatever threshold to radar reflectivity, is key to success. So yes, definitely we have hired, and we are still hiring professionals in this domain.
There were actually, I think, 2 questions specific to Leithà in terms of like, do you have metrologists in the team? So I assume the answer is yes. Based on your response.
I don't want to, I don't want to say it improperly, because I know that the terminology is key again.
Yeah.
So I don't know whether we have hired in the past a meteorologist, strictly speaking, but for sure we have environmental engineers, we have physicists, we have experts that build their expertise in academia, mostly in academia. In the space of weather and climate data.
Thank you very much. Maybe one of the others, how would they also get involved in companies like you have, basically? So would they just knock on your door and look for adverts, or is it what's the entry point for bigger companies to hire, well, people from coming from the universities, for example, or yeah, what are the typical ways of getting in the business? Anyone?
Sorry, I lost it for a moment, the connection. Can you repeat the question? I didn't.
So the question was, what are kind of good entry points for if there are metrologists now here in the audience, and you would be interested to kind of get into contact with bigger companies and also insurance cases and these kind of things? What would be good entry points for them? Just apply out of the blue into job adverts, or?
I can try to talk for consulting. Okay, which is a little different market with respect to final customer. So perhaps then Paolo, if he wishes, can complement for his industry. So it depends. So I can speak for the competencies and the types of profile that we look for. So we do not actually have a prototype of of data scientists or of professional that we look for. That's mainly because the types of projects that we work on for companies are quite heterogeneous. Okay, so we can it can happen that we work for retailers in digital marketing. It may happen that we work for telecommunications in operation and maintenance, predictive maintenance and stuff. So having very skill-specific roles can be constraining, let's say, in some sense. So we typically tend to value a little bit more the attitude, the open-mindedness, the flexibility, and of course the the soft skill of the people, because there's a little more let's say a horizontal usage of the skills in many different sectors and many different applications, that having very skill specific or people with very vertical and specific skills can be hard for us to manage. I'm not saying, of course, that very vertical people cannot do consulting. Of course, that's not true. It may happen, of course, that there's the need for being very very competent in a certain field. The ways in which people can get into this kind of job, of course, are the I would say, as a generally speaking, to be able to stand out. Okay, it's a general concept, but I think that it checks out, because demand is increasing for jobs like this, but also the offer of so in terms of people that get into this kind of job is increasing as well. So how to differentiate, how to stand out with soft skills, but also how say how willing, how into how much passion the person puts into the job, and how much they stand out in the recruiting process, and also in maybe in the university, or on social media, let's say, or on platforms such as medium.com. Those platforms can be an entry point to
yeah. This also sounds a bit like you're not searching for the perfect employee who is kind of skill levels, or has already 5 years of experience in business and stuff like this, and has kind of domain knowledge, but also it more sounds like you're also hiring and then forming as well. So as long as people are flexible, they can basically come from vertical structures, but they would need to be, you would assume that they would work horizontally anyway, and kind of get the skills they need for different domains as well.
Yeah. Also, technology comes to help. So many steps of the model implementation pipeline are being automated by technology, by advancements, by innovation in the market. So auto machine learning, or processes for machine learning operations, are automating and simplifying some steps of the development process. So being maybe in the future the trend will continue. So being very competent and technical in some aspects will help, of course, if there's the need to go very deep and in vertical with the applications. But for general purpose applications, some other aspects will be important as well.
Thank you. Let's pick another question. This one I found interesting. So Bisra is asking, are your systems fully automated? Does a real person confirm the risks that are produced by machine learning algorithms? So and I find this question interesting, but I also find the perspective interesting, what we will do in 10 years from now. So whether this will even kind of get more and more automated, and everything is statistics in the end. So
I can try to to answer this question. Well, the first answer comes to my mind is I wish. So I'd like that the system would be fully automated, but at least for our side on the presentation, you see that they are not. So there is always a real person backtesting the findings of the machine learning algorithm, especially in our perspective. So we are not experts of meteorological risk. So the way we proceeded is really we can have an analysis of the results based on standard machine learning criterion, so measures of errors and accuracy. But then we always work side by side with the meteorological expert from RED, that is the only one capable of validating the reality of the results that are presented, discerning if they are if our models are overfitting the data, or if the results are really representative of risks associated to a specific area, and for reason because often the client also wants an explanation of why an exposure has been associated with a given risk score, and that the algorithm cannot produce any explanation by itself. So the human intervention is very important, especially in the backtesting, but also in the explanation phase.
Justification.
Yeah.
Interesting. Any other opinions?
I can totally confirm on this. So I'm totally on the same page with Paolo. In fact, as I cited before, the human aspect is quite fundamental also to gain confidence in these kinds of applications. So a proper change management is fundamental to allow people actually to rely on a box that outputs numbers between 0 and 1 as a confidence, but having confidence in those numbers for core processes in companies that can move millions of euros, hundreds of thousands of euros, and taking decisions based on a software without human, at least a human control and validation over the outputs is quite risky. And the risk is not only to lose money, which is bad, but the other risk is also to lose confidence in how these models work. Okay, any industries, it's quite important also if we want to advance in terms of technological innovation. Okay, so we need actually to also manage the confidence of people in systems like this.
Thank you very much. FILIPPO,
I can confirm that the very same holds for us as well. Also take the chance for trying to answer to not only to this question, but also to the last question I see in the chat. Because in this case, of course, in the case of insurance, regulation comes into play. So having a man in the loop, allows to, I mean, no decisions are nowadays taken directly from a machine. The machine can, support claims handlers when it's about a claim, or insurance agents when it's about, underwriting or not an insurance contract. But there's no decision that is fully automated, except very tiny little use cases like, when Alessandro was delivering his speech. One of the use cases he talked about looked quite similar to what we do in some cases when we have to send communications to the clients, like whatever, your claim has been opened, or stuff like that. In that case, the machine takes the decision, but the decision is, what's the best time to optimize the click-through rate for the digital communication, what's the best time to send the communication to the client. So yes, it's process automation, it's some ancillary work that we do, but the very core of the insurance business still has a man in the loop, also due to legal and regulatory environment.
I think you meant this question, right? That you're referring to.
Yeah, exactly. Okay. Exactly. Or I can add something about the ethical issues.
Yeah,
sure. Which is yes, of course. But I'll try to be brief if I can. One thing is being able to estimate the risk that you are putting on your book when you underwrite a policy. Another story is charging your client for that very price of the risk.
Yeah.
But if we are not able to understand what kind of risk we are underwriting, then we are not able to build a sustainable risk pool. And if we are not able to build a sustainable risk pool, then that kind of risk cannot be insured by definition. Because if the risk is not if you cannot estimate that kind of risk, you cannot build a risk pool, and then the entire community cannot insure against that kind of risk. So yes, we do have an ethical issue, not only in car insurance, but imagine what happens with health insurance. But of course, if you can estimate the risk, then you can, you can balance your marketing strategy to, charge a bit more who needs a bit less that kind of policy, to enable who really needs that kind of policy, to purchase that kind of coverage and have a sustainable risk pool in the end that is profitable for everybody, for all the stakeholders, basically.
So this sounds a little bit like this is a problem, but it's not per se a problem of machine learning. It's more like a problem of insurance itself. But the machine learning may accelerate the problem a little bit more by having kind of more extreme judgments of risks and stuff like this. Yeah. Okay. Interesting. Let's go to the next question. Extreme weather events prediction is of paramount importance. What are the steps taken to tackle it most efficiently and effectively? And I really like this question because I know from experience that extreme precipitation events, for example, to predict them is very difficult. And even if you, again, it's a question also of the data, right? So if you have a 1 in 100 years event, for example, and you only have 20 years of data, then by definition, you would probably miss some of the extreme risks. So is there anything that you do to kind of cover in particular extreme events?
So what we do, at least with CRIF, is to use time series that are long enough for capturing the frequency of these events, and also data that are capable of projecting the frequency of these extreme events in the future. Because, as mentioned before, climate change will have a big role in determining frequency and severities of extreme event for the future. So what can be done in this case is to resort to climate scenario that are provided by the scientific community, such as the IPCC panel on climate change, which connect the projected degree of emissions, what are called the representative concentration pathways, to expected frequency and severities of extreme events. So the scientific community has published a range of representative concentration pathways which correspond to different ranges of increase in the expected average global temperatures at 2100. You can use these paths of emissions in order to feed meteoclimatic models for computing frequency and expected severities of extreme events, given the uncertainty of the case, clearly.
Thank you. Any other comments from?
I think you have seen something that we do in this space, because what we call, I see that the names that we give to projects also, generated some kind of, like Metropolis. But you have seen the Zeus Now project. That is what we do for very short range prediction of events. It is basically an adaptation of a model that has been developed by DeepMind, by Google. So what we do is actually that we try to kind of send a call to action to our clients to protect their goods when they can. Of course, when the good is a car, they can protect. When the good is themselves, they can do something. When the good is property risk, they can do nothing, or almost nothing. When it's about agriculture, in some cases they can do something. So what we do is basically we produce this kind of very short-term alerts. And by the way, you have seen the performance, a bit of the performance of the adaptation of the DeepMind model for the case of Marche last September 2022.
Yep.
I think we have alerted around about 200,000 clients. I hope that someone reacted to the call to action. And yeah, that's what we try to do. We know
that's interesting. Yeah.
We know that estimating trends is very difficult. Estimating frequency is very difficult because you would need very long time series. What we can do is, put ourselves on the other hand, on the other side of the timeline, and predict very, very short term, and then alert someone.
I think this is actually a weather event. I mean, I've seen the event in the presentation. I was wondering, I think that was a weather event that was also very difficult for conventional tools. And I was kind of quite impressed by the prediction. But then my first question was kind of in my mind, like, did it actually change anything? Like, did it actually went operationally out? But now you're saying that you actually alerted 200,000 people. So that's quite an impact. That's where we want to be, right?
We actually see a significant reduction in car insurance. We see a significant reduction in terms of the frequency of claims after we launched this kind of alerting system. And I really hope that someone during the very last catastrophe in Marche got our alert and did something.
Yeah, thank you. This also fits to this question here, what you just said. I mean, you basically just said that you are using the Google, there's this nowcasting DeepMind paper together with the UK Met Office, right? Very interesting paper, I can only recommend. And this fits to this question here. Do you develop your own models for time series forecasting, or do you fine-tune existing model available on the web? And if yes, which ones? So we have already DeepMind in the mix. Is anyone else using any of the existing tools, or are you more like developing in-house?
I can answer. Yeah, it depends. Okay, we typically it depends on the level of accuracy you want to reach, and it depends, of course, on the type of application you are developing. If you again need to be super precise, super accurate in the forecast, or if you're just looking for insights to bring to business stakeholder. We typically use as a best way to go pre-trained model or ready-to-go models to benchmark our custom solutions. So we can use, for example, I don't know, Profit as a library, or other publicly available models, or even auto machine learning packages to have a baseline regressor for time series, and then we can tweak it a little bit, gain knowledge from the model that and the accuracy levels that are given in output by the models, and try to improve it a little bit. Of course, it also depends on how much time you have for developing those models. If you're really tight on the schedule for the delivery, or you have more time to improve the results.
Thank you. There was the question which paper it was. It was basically a paper by Google DeepMind. I think the lead author is Simon Ravuri, who's actually going to be in the webinar next week here. So if you want to hear from him in person, you can also, he's also going to be there.
Say thank you to him by
yes,
myself.
I will. Okay, perfect. I have a general question that comes from me personally, basically, since I work in a weather prediction center, basically, what data is missing for you guys? So what would you need if you could make a wish list for your next birthday? What data would like to see that would really help you to improve your models? I mean, we have already seen mentioning of ERA 5 and reanalysis data. We've already seen mentioning of weather forecast data as such, but is there anything else where it's clear that we're missing something?
Yeah, I take the question immediately.
Okay.
High resolution, high frequency satellite imagery.
Okay.
At an affordable price.
Yes. Anything else?
I'm aligned with Filippo with respect to high resolution data, because downscaling is really, is really a big job. But on top of this, I raise a point on one data which is very difficult to collect, which was requested by one client recently. which is not strictly a meteorological data, but is strictly connected with claims, which is public natural disaster relief schemes. Because this is a kind of data that can make a huge difference in terms of real damages that must be suffered by a counterparty, for example. No? So if a counterparty is located in an area with a high meteorological risk, machine learning algorithm will probably attribute a high risk score, but the real damage that she would suffer if a public relief scheme is existing would be way less considerable. And this is a kind of data that is very difficult to collect because it depends on national regulation. Governments may change, so the policy with respect to this information may change. It was curious that the client asked this information to us. This demonstrates quite a good level of maturity with respect to the topic, but unfortunately, it's a data that will be very costly to collect and homogenize in a unique database.
Alessandro, any opinions?
I cannot add more on
Okay.
The type of data that Paolo and Filippo shared. We used to work on such a broad type of use cases that basically in each project I can make a list of at least 20 or 30 items that are missing, and most of the times it's related to a proper, let's say, quality, high quality data for people, for customers. So personal data is typically something that's really missing, but sticking to the weather and climate, I think that Filippo and Paolo said it all.
Thank you very much. We have 6:30 here in Germany now, so I think we're finished with the webinar in principle. Please join us tomorrow. Tomorrow we're going to have another webinar where we're going to have 3 SMEs, so small and medium-sized enterprise speakers. It's going to be a fairly similar format, again with kind of short presentations and then questions. And otherwise, I hope you enjoy the MOOC so far and have go through the modules that are appearing every week. And thank you for participating. Thanks so very much to the speakers in particular, also to Federica. And see you at the next event. Thank you.
Thank you very much. Bye.
Thank you.
Thank you all.
All the best.
Bye-bye.
Bye, thank you.